So guys, let's start solving this problem. I will take the same example, which is given here in lead code. Let me copy this. Okay, so the nums, this array, somewhere here, and I'll start with index I and nums of I, 2, 3. So this is our given input. And let's try to solve this problem using dynamic programming approach from the bottom up. We'll start with the base case 0, 1, -2, and 4. And this would be our final solution dp of the last index. Here in this case, let's store this because this is a sort of problem where we have to find the maximum product of a sub array, which should be contiguous. So it would be very much like a sliding window type of problem. So let me also maintain one final result, which will store the value, which is the maximum, when we keep on following up with all the dp0, dp1, dp2, and all, and it will store the maximum value out of all of that. I'll store that variable in result. So it would be, so besides storing this result, right, we will also need to have a variable to store. Maybe let's start with dp first. So dpi. So this will be storing whatever is for the 0th index, and it takes 0 and 1. And besides that, we also need to store current max. So current max variable. So there are like two variables. Result will be the final result, which is the maximum of the current max and the dp of I. And whenever we see that the value is going down for a current max, I mean, if the current max is not considering of this contiguous array, then we will drop and we'll reset that current max to 1. So by default, I'll start with 1, because for current max 1, I mean, if I multiply with whatever index except 0, it would be still the same number. For 0 is an edge case, which I will cover very soon. So let's start solving this problem first. And the result would be max of the result that we are computing throughout when we calculate the value and current max. So again, let's revise this. We'll store dpi for each of the bottom up case. I mean, start with 0 to 3. Result would be storing whatever we have found the maximum out of the result, the current result and the current max. We start with 1 and we keep on calculating the various dp values of current max. And then besides that, one more thing is that the result, right? So the result, just think about it. If we are given any array, and if I just take individual element out of it, if I just this is another sub array. This is another sub array. Just taking one element out of it, just taking this element. So at least the result, the maximum number would be the maximum of the sub array. If I don't find any current maximum out of any of the index, but if I just take each individual element here in the index, so the maximum result would be at least the maximum of this whole array, right? So maximum product sub array, we can say that by default the result would be 4, because 4 is the maximum number out in this array. And if we just take out each of the individual element, at least we will find the maximum number, which would be at least maximum product sub array. So we can say that the default value of result is we'll start with 4, which is the maximum of this array. Yeah, so as discussed, the default result, I mean, we start with the max of the whole array, which is 4 here. Now, and the current max as default is starting with 1. So now enough of talking now, let's start calculating the values here. So we'll just start with dp0. So as we have already found that if we take all individual element, I mean, the maximum sub array is the number itself. So for dp0, which is 2, I will again mark this like this, it's easy to understand. It would be 2, right? But before we solve it, we actually also need to calculate the current max for each of them. So let's store it into a variable, let's say temp1, and I will mark it as correct, sorry. Temp1, which would be current max multiplied by nums of 0. I mean, this current index that we are checking. So if I do this, it would be current max is 1 and nums 0 is 2. So it would be 1 multiplied by 2. So it would be 2, right? So this is the temp1, and the current max formula would be, so the current max would be the max of this temp1 that you calculate here and the number itself. So for current max, it would be max of temp1, that is 2, and nums I is 2, which is again 2, right? So here we are also, so just to iterate it, that here we have to also maintain this current max so that we actually follow the sliding window approach for each of the DP that calculated. And the result here would be max of result and current max. So the result here would be 4, because the default result we have chosen as 4 out of 4 and 2. So the max is 4. So result would be 4 for DP0. So I will mark it as 4. Okay. So these are the two variables. We calculate temp1, which is current max multiplied by the actual number itself. And then we calculate current max, which is the max of this temp1 and number, because you just think about it, we are storing this, we are using temp is actually working as an accumulator for each of the product array that we have found so far. And we are storing this into current max. And the result is actually the current max, maximum of current max, and the result itself.